This having a radius r, both are having same radius. Both were having same radius. Okay, there's a kept on rough surface. Okay, there's a sphere A, there's a sphere B, this is a hollow sphere. We have to find out the time period of force. Friction is sufficient for pure rolling. I think this was the question what we had. Okay, now what I do, I'll just stretch the spring. I'll make problem little bit. Diagram little bit small will make it. So it'll be easy for us. Okay, I'll stretch them. Okay, now the spring is stretched and it will be released. Oh. So what is this is the reference point. Let me have. So both are stretched and released. Okay, now when they come to a certain position, just simple diagram. So diagram, it will be very easy to understand. You'll find it will be very easy for you to understand this one. So when they come to this particular position, okay, what is the state of initially what happened? The spring is elongated. So how much of spring force will act here? Kx naught. Here Kx naught. Okay, agree this. So now still the spring is stretched here now. Okay, you have to is asking us to calculate the time period of oscillations of this one. So what is the elongation of this? Let it be x1. Elongation of this be x2. Then how much of spring force is acting? Say kx. This is the idea. This is the t equals 0. I released at any time t. Okay, fine. This is the assumption is what we are making. Already reduced mass concept we have done. No, the similar to this, it is same thing here. So this that hollow sphere. So what is the direction here? The friction must act. We know it, and the friction here will be like this. The acceleration of this be a2. The acceleration of this be a1. Now let me assume the motion with respect to point of contact. With respect to point of contact here. So what is the angular acceleration of this? This will be alpha. So here I'll assume that as it is a pure rolling, no slipping. So I can assume that the whole body is having only rotational motion about this particular point, about the point of contact. So let me write, this is P1, this is P2. So about P1, about point of contact P1. So what is the net torque acting? Kx into R should be equal to IP1 into alpha 1. And though it is rotating about center of mass, but as it is pure rolling, if you come and stand here, what the whole body, rigid body appears to be rotating about the point of contact here. So still let it be like this. Huh? It may confuse you. About point of contact, we are defining the net torque Kx into R equal to IP1 alpha. So what about torque due to friction will be nullified because it will intersect axis of rotation. Now what is IP1? So this should be equal to Kxr. This should be equal to IC1, will write it. IC1 plus MR square into alpha 1. Okay, this will be hollow sphere. What is the hollow sphere? Will be 2 by 3. Now, what is if whole body rotates about center of mass? Okay, this alpha one, if you'll find very difficult. Or let it be here only because you are quite comfortable. So for pure rolling, what pen A1 should be called R alpha one. So in place of alpha one, what we can write it as A1 by R. So therefore, this will become Kx is equal to 5 by 3 Ma1. R will get eliminated. Okay, keep this in hand. But what is x? X is the elongation. X is the elongation of the spring, and x1 is the displacement of center of mass. X and x1. So acceleration should be proportional to displacement of center of mass of the hollow sphere. But we have x here. That x should be eliminated. So strictly, what is x? X is total elongation of spring. And what is x1? X1 is okay. I think this is the basic idea, no? Total elongation of spring and displacement of center of mass. It is. So we have the conditions like this here. We have to replace x in terms of x1. For that, let me apply conservation of angular momentum. What is the state of this? They were released from rest. So in this situation, what happens is release from rest. What is the state of them? They will have a velocity at this particular point. So what was the initial angular momentum? 0. Final angular momentum also should be 0. So about point of contact. So I'll apply conservation of angular momentum LP1Z. Initial angular momentum will be 0. That is from the final angular momentum. So LP1 final. Initially, both are released from rest. Finally, what is the angular momentum? MV1. Okay, this will be a total. It will be IP1 into omega 1 minus IP2 into omega 2. So V1 equal to again R omega 1, the overall that one. So this will be, what is IP1 should be equal to, just now we have calculated, no, moment of inertia, it should be equal to 5 by 3 mr square. Omega 1 is V1 by R minus this will be IP2, moment of inertia. Okay, finally what we are getting is 5 by 3 V1, no? V1 should be equal to 7 by 5 V2 or 25 V1 is equal to 21 V2. Then I can also write this as from where that is because V1 equal to dx1 by dt. So this is and x1 plus x2 is what? Is x. Now I'm going to take help of this condition. So x1, I should replace x2, no? So this will be 25 x1 by 21 equal to x. So therefore, what is x equal to 21x by 46. Yeah. Okay, now I got the value of x1. This value of now x in terms of x1 has to be substituted. Okay, this I'll call equation 2. I think I'll go for next page. put 2 in 1. So x in terms of x1, one more step. X in terms of x1 is needed, no? So therefore this will be 46 by 21 x1. Okay, put 2 in 1. So therefore it will be k anybody? So for the simplification. Three into 46, this is 5. 46k by check once calculation. I think somewhere I'm x2 is 25 x1 by 21. So therefore x I'm replacing, no? So 21 plus 46 x1 by 25. Yeah. Anybody? Can we simplify or we have to leave it this much only? Twenty-one, 46. Can we simplify this quantity? Not possible. Huh? 46 by 35. Huh? Okay, good. Yeah. 46 by 35. Okay, therefore the time period will be 2 pi. This will be your answer. Okay, this will be little bit, actually it's having pure rolling. If you describe the motion about point P1, it will have only rotational motion. So that's what we are taking help of this idea. They're having pure rolling, where again A1 equal to R alpha 1 only. You are describing the motion about point P1. Okay, we'll take the next one. I think this problem we could not get time. Okay, let me explain that first.